Alright, so this is going to be the solution to the third problem in the grind 75. This is merge two sorted lists. So just to refresh, we're given two singly linked lists. Both of them are sorted. We want to merge them into one list that is sorted, and we can only do so by using the actual nodes of the original lists. So we can't create copies of these nodes. So a pretty key insight that I missed in the last problem was that I didn't use a dummy node. And that sort of would have helped with a kind of like an edge case um, where you make the comparison between the first two nodes um, and you try to use one of the nodes to begin creating that linked list. um, you're you would be adding it to nothing. So if we start off with a dummy node, we can just have a current pointer and have it point to there. We can just say, the current dot next becomes whichever is the result of this. So in our case, in the way that I was doing it, it would have been 1. Um, and then we would have moved 1's pointer over, and this would still be here. We would compare, and again, we would also have to move current over, current equals current.next. Then we would do the comparison, see this one is less. Then we would move this pointer over, and it should be this. But you sort of get the idea how that would work. We do current.next is equal to that, and then we would move this afterwards. But the dummy node helps to alleviate a kind of weird case where you're adding to nothing in the very beginning. But we do have to do the check after. We will be iterating through these linked lists for as long as there are nodes in them, but as soon as there are no nodes in one of them, or both of them, we will have to check if one is empty, then we will tack on the rest of the other, and vice versa. So let's look at how we would write this. So in my solution was something like this. For now, we're going to comment it out, and we're going to look at what the actual solution would be. So I'm just going to, for now, I'm going to put this down here. I think I want to do that too. Okay. So first thing, I'm going to create a dummy node. So we can say list node dummy is equal to list node, like that. We should probably say new list node. And we will also need a current pointer. So list node current is going to be equal to dummy for now. And then for as long as list1 does not equal null and list2 does not equal null, then we're going to make the comparison. So if the val at list1 is less than the val at list2, then we are going to want to set cur.next equal to list1. Let's see. We're going to want to point to that head there. Then we're going to want to move list1's pointer. I'm going to say list1 is equal to list1.next. And then we're going to say, I think that should be good actually for now. Else we're going to say current.next is equal to list2. We're going to increment list2's pointer. It's equal to list2.next. Of course, we're forgetting semicolons. And then outside of this, we want to do this regardless. We're going to need to update the current pointer. So we're going to say current equals current.next. And again, once we exit out of that while loop, we're going to have to check for empty lists. So if list1 is equal to null, then we're going to say current.next is equal to list2. Else if list2 is equal to null, then we're going to set current.next equal to list1. I don't want to have semicolons there. And then we're going to shed off that dummy node, but that dummy node points at the beginning of the list, so we don't have to worry about making current point to the front. So we can simply return dummy.next. And I believe this should work. Let's give it a try and let's see. Quick run through made dummies. Then we're going to set compare. We want the current next equal to what the head of list 1 is, and then we want to move, yeah. So this looks right to me. And let's submit and see if it works. Okay, so faster than 100% of online submissions. That makes little to no sense. Okay. That's the solution to this problem. Okay. And I will remember to use the dummy node next time around.